Alright, now we're going to look at section 2 of chapter 4, which all is about shapes of distributions. So we talk about distributions a lot throughout the rest of this semester. When we were doing that cane toad activity on the first day of class, we were looking at what we call sampling distributions. This one is when we're just looking at regular distributions of data sets. And what we're going to be looking at here is really the idea of what histograms are going to look like when we're looking at distributions themselves. We're also going to be looking about where the mean, median, and mode are in distributions of data sets as well. You're going to have to be a bit more visual in your imagination here in this section. I'm going to go through and show you how to visualize distributions. I find some students have trouble with this, whereas some people that are really artsy and that sort of stuff can kind of pick up on this pretty quick. So if you have trouble with it, let me know, and I'll be more than glad to help you. So when we look about the shapes of distributions of data sets, again, we're thinking about what the general shape of a graph of a histogram would be. And what we're trying to do is we're trying to think about what a histogram would look like and what it would look like if we kind of drew a smooth curve over the data set when we graph the histogram. And remember, with your histogram, you are looking at the data on the bottom on the horizontal axis and then the frequency of it occurring on the left-hand side. And we always bin our data when we're looking at histograms because normally we're looking at continuous data sets or things that are going to take on many values. They can be discrete as well, of course, but usually we have things that can take on lots of values. When we look at the shape of a distribution, we're looking at three things: the number of modes we have, the symmetry or skewness of the distribution, and what the variation is. For our cases, variation is a bit hard to visualize because depending on what scale we graph our histogram, the variation isn't going to change much. I'll show you what I mean here in a minute. But the number of modes and symmetry or skewness are things that we should be able to pick on quite easily. So first off, the number of modes. So for the uniform distribution, we would have something with no modes. So it would look like a straight line straight across. So you'd have a bunch of bars that for the most part were, if we drew a line across the top of the bars, you would have a horizontal line. And that would indicate there's no mode. This would mean that something is equally likely to occur. And usually when you think about things with probability, the games of chance and such, things are equally likely to occur. Like if we asked, what's the probability, or let me try to think of it. If we were trying to roll a dice has 6 sides on it, and we want to figure out what the probability is of rolling each number, 1 through 6. Well, since they all have the same probability, then the probability is going to be uniform. It's going to be the same. The next one we're going to look at is when we have a single peak distribution. So we have one mode. So for the most part, most of the data will peak around one mode. This data set is showing you where it peaks and it looks like it's in the middle. It's not necessarily in the middle, but it's going to have just one main peak of a distribution. And I'm going to show you some examples of that here in a minute. A bimodal distribution is where you have more than one mode. So you might have 2 peaks. You very well might have more than that. You might have 3 peaks. Here's a trimodal one, for example. I don't care if you say bimodal, trimodal. I tend to say multimodal because it has more than one mode. Usually you can see if it's 2 modes or not. You can just say that. But we can use these words bimodal and trimodal when we're thinking about the number of modes in a data set. I'm going to look at some data sets here in StatCrunch just to give you an idea of what's going on. So this data set here I really like because it is looking at a lot of different prices of diamonds. So it's looking at, if I scroll down here, it's got over 53,000 diamonds in this data set. And what it's looking at is the clarity, depth, price, all types of things, length, width, depth in meters of different diamonds. So what I'm going to do is graph a histogram here. I'm going to look at the price because that's actually an interesting one to graph here. Alright, so here's a histogram that shows the price. If I thought about drawing a smooth curve over this, you would have something that looks sort of like this. It would be like a little mountain peak. But you can see here that the peak of this mountain is at the top. This has one mode. Alright, the mode occurs here in the middle, so we would call this a unimodal, single mode histogram in this case. Alright, so it just comes up and then it goes back down. Alright, so this would be one mode. I have another data set here. This one is looking at the Powerball lottery and looking at what the numbers are and what number occurred. So when you draw the ball, like they draw 5 balls for the Powerball, which number was drawn on the date. And this goes back to 2006. So it's 10 years worth of data. So we're looking at the draws on each individual date and what number was drawn. Now technically for this game you should get a unimodal graph when we draw it, because each ball has an equally likely chance of being drawn. So if I look at the histogram here, I'm gonna look at all the numbers 1 through 5. You can see it's almost uniform, so it's almost a straight line across. There's definitely not a mode. You can say this doesn't have a mode for sure. And here these two drop off. Actually, it's pretty interesting these two drop off because actually, I'm not going to tell you why. We're actually going to look at a lab of this later. I'll just ignore these two bars for right now, the 60 to 70 range. But if you look here, it's pretty unimodal. There definitely is not a single mode that comes out of this for any of these. We would expect it to be flatlined just because they have an equal likely chance of occurring, but it's not, but there's definitely not a single mode that comes out of that. So keep that in mind when we're looking at this. Alright, so that's the first thing we're looking at is modes. So let's think about some examples here and what sort of mode we'd look at. So we're looking at uniform where there's no mode, one mode is a single peak, two modes, or three modes. So here's some examples, and let's think about how many modes we might expect to see. So the heights of 1,000 randomly selected adult women, hours spent watching football on TV in January for 1,000 randomly selected adult Americans, weekly sales throughout the year at a retail clothing store for children, and the number of people with particular digits 0 through 9 in the Social Security number. So the heights of 1,000 randomly selected adult women. So you think about women, or men in general, most women tend to be around the same height, like between 5'3", maybe 5'5" tall. So for the most part, you're going to have a mode in the middle where most people will be at a certain height, and then it'll kind of taper off. You'll have some on the lower end that are shorter, some on the higher end that are taller, but for the most part, most of the people peak around the middle. So that one would have one mode. You'd have a single peak. Because there is an average. And we had talked about the heights of 1,000 randomly selected people, you would have two modes there, because you'd have women would have one peak on one end, and the men would have one peak on the other end, because there are two different means for men and women. Hours spent watching football on TV in January for 1,000 randomly selected adult Americans. This one I actually got from your textbook, but they say here that there's two modes, because you have either people that are watching TV a lot in January, that are watching like all the playoff games and stuff, so they're going to have like a high peak on one end where there's a lot of people watching TV, and then you're going to have a lot of people on one end that are not watching. They might watch like 1 or 2 hours, especially they might watch the Super Bowl, because that usually occurs in January. That was in February last year, but that could be on the other end. So there's two different ends here, so you have people that are either watching a lot and people that aren't watching a lot, so they're saying bimodal here. Weekly sales throughout the year at a retail clothing store for children. This one we'd say bi or trimodal, mainly because there's going to be peaks where you have maybe people buy a lot of clothes when the school starts again, like in August and September. Probably in December, a lot of people buy clothes for Christmas. Then maybe again in about spring to get ready for summer. So this could be more than one mode just because you have different peaks times where people are buying clothing. And then the number of people with last digit 0 through 9 of Social Security numbers should have no mode, because the last digit of everyone's Social Security number has an equal likely chance of occurring. So the number 0 through 9, since there's 10 of them, there's a 1 in 10 chance that you would get any one of those numbers, so it should be a flat line across. So 0 through 9 all have an equal likely chance of occurring. So if we took a poll of a bunch of people, then you should see that the number of occurrences is pretty even across the top. Alright, the symmetry of a graph is if its left half and its is a mirror of its right half. So you have the mode that occurs in the middle. You have a line of symmetry, it makes it symmetric. You can also have like a trimodal or even a bimodal graph. As long as the left and right hand side look the same, we would call them symmetric. Now the skewedness is something I want to make sure you know a lot about. We're going to talk about this a lot. So distribution is left skewed if its values are more spread out on the left side. It's right skewed if its values are more spread out on the right side. So this does get people a little bit confused sometimes. So in a left skewed graph, there's more data over here to the left. So outliers are at low values. Okay, so see, even though most of the values are over here on the right, it's left skewed because the tail tapers off to the left. So that's what makes it left skewed. Same thing with the right skewed graph. Its outliers are over here to the right, even though the peak of it is to the left. It's right skewed because it trails off to the right. Don't get those two confused. Those are easily confused. So left skew goes off to the left, right skew goes off to the right. And then a symmetric graph is one where you're not left or right skewed, it's just right in the middle. Now do remember these things here though. This is important. This is in your textbook too. But whenever you're talking about where the mean, median, and mode are in a graph, for left skew, well, for any of these graphs, notice that the median is in the middle. And that should be a good place where you start, because the median is always in the middle for any of these graphs, because median's in the middle, right? The mean is lower than the mode in a left skewed graph. The mode is always the highest point, all right? So notice the mode is the highest point here in a left skewed graph, the highest point in a right skewed graph. And then the mean is going to be to the right of the mode and the median in a right skewed graph, and it's going to be to the left of the mode and median in a left skewed graph. For me to remember this, I like to just draw a little left skewed or right skewed graph, and I'm like, all right, the mode's the highest point, let me draw that here. I know the median's between the mode and the mean, so this is the mode, the mean's here, the median's in the middle. So I know that the mode is higher than the mean in a right skewed graph, and the mode is higher than the mean in a right skewed graph. For a symmetric graph, they should all be about the same. So wherever we see the mode and mean and median, they should all be about the same in a symmetric graph. And I can show you that here too. So let me show you in StatCrunch. If you look at this graph, that one's not exciting. Let's go back to this diamonds one. So this diamonds one, I have this graph. This graph is pretty symmetric, because you see you have this outline over here. If we ignore that and we drew like a little curve, it's pretty symmetric here. But I can actually show you on this graph where the mean and median are. So you can see here these red points and green points. The green one is the mean and the red one's the median. So you look here, the median is 57 and the mean is 57.5. They're dead on each other, and that's kind of one of your keys, like, oh, they're about the same, and this must be a symmetric graph, and okay, this is a symmetric graph. Alright, so let's think about how many modes you'd expect for distribution and whether it would be left or right skewed. And put these up here first. So the reaction time of 500 randomly selected drivers measured under standard conditions. Alright, so we think about this one. It's something that's kind of natural. So people are usually going to have about the same reaction times to things. So I would expect it to be uniform, or not uniform, I'm sorry, symmetric. And I would have one mode, because for the most part your reactions are going to be right in the middle, but you're going to have some people that take forever to react, which would go to the right, some people that take no time to react will make it go to the left, but for the most part it's going to be symmetric. You're going to have a mode in the middle. Alright, the heights of 500 male students, half of whom are adults while the other half are 8-year-olds. For this one, it should be two modes. And since you have 250 that are 8 and 250 that are adults, you're going to have one mean for the adults and one mean for the 8-year-olds, which means you're going to have like two peaks in a graph. And it would be symmetric because you have equal amounts of both on either side. Remember that the height of the graph, let me go back here, the height of this graph is always the frequency, it's the count. So even though one of them might be higher than the other, it's just the count that we're looking at for those graphs. Okay. The weights of cars in a fleet consisting of 500 compact cars and 50 delivery trucks. Well, for this one, you're going to have a lower weight for the compact cars and a higher weight for the delivery trucks, but notice there's more compact cars than delivery trucks. So since the delivery trucks are going to cost more, you're going to have you're going to have two peaks, two modes, but the lower mode is going to be to the right, but the higher mode is going to be to the left. So that makes it actually right skewed. Oops, that's not right. That should be right skewed in that one, because you're going to have that shorter hump to the right. Sorry about that. That should be right skewed. Number 4, the ages of people who visit Disney World. I always get an argument about this, but I'm going to say why I say it's one mode and right skewed. I say it's one mode because most of the people visiting Disney World, you'd think they're probably younger. Most of them are like kids and that sort of thing. So I would think most of the people would be in the left because those are the shorter age, smaller ages, and then to the right would be the higher ages. Like people that are over 60 are probably not visiting Disney World, so it kind of levels off if you get older. But some people argue with me that all types of people visit Disney World, so I don't know. I think it's one mode and right skewed just because you have a lot of younger people visiting. And the ages of 1,000 randomly selected dementia patients, this one will be left skewed and one mode because most of the people that had dementia are older, So I'd say the average is probably in the 70s or 80s somewhere. So you get a peak to the right, and then people that are like our age, from like 0 years old up to like 30 or 40, don't have dementia as much. But as you get past the age of 50, it starts to peak and go back down. So that would be one mode in left skewed. It's very hard to find these left skewed examples when we're talking about distributions. But this is a good one. Whenever age is always a good one that pops up when we think about the skews of distributions. Variation describes how widely data are spread out about the center of a data set. So low variation is one that has a really high peak and the data is very short. Moderate variation is a little bit more symmetric, more spread out, and high variation has a low peak and it's quite spread out. So again, if you look at this one is a really good example of a graph that has low variation. You see how it's so narrow? That's a very low variation graph. Let me graph another histogram of this one. Let's look at the length of the diamonds. I think that one's pretty symmetric. Yeah, this one's a little bit nicer. This one's a little bit more spread out, so I'd say we have a moderate variation here. Not very symmetric though. Maybe we could chop this one down a little bit. But let me play with the mean and median to see what you think they are. Oh, they're right on top of each other. Okay, I'm going to call it symmetric just because of that case, because the mean and median are right on top of each other. But this one has a higher variation than this one because this one is tighter together, the table one that we're looking at, and then this one is a little bit further apart. But again, variation is something that's really hard to look at just by eyeballing it, because most of the time you're not looking at two things compared to each other. We're going to look at this more when we look at standard deviation. That'll tell us a lot more about variation, but for this section, that's all we're looking at there. If you have any questions, let me know.